So we are going to create a file handle in modern C++. All of the codes discussed over here will be available on GitHub, so make sure to check that out. So without any delay, let's start. I have pragma once so that this file, when used in an application, does not get called multiple times. Now I'll introduce some includes from the standard library. So we have file stream, fstream, then we have memory because we'll be using shared pointer for string to read the data into a buffer. Also we have the exceptions. Also we have the standard exceptions, and lastly vector to handle the binary data and to store it somewhere. Now we can start with class file. I'll just call it file. And over here we will have two sections. So public and private, of course. So first, to work with file, we need a file stream. So I have used unique pointer over here, and I have passed in the type as file stream, and my private variable file stream is ready. Now I'll create the constructor and destructors. So file, and my destructor will also be this. This file stream needs to be opened using a path and what mode we want to open in. So to specify those modes, I'll define two structs. Over here you can see I have mode which is read, write and append. So we can open a file in read mode or in write mode or in append mode. For read mode we'll just get the content of the file. For write mode it will just overwrite anything if there was and write the new content we want to put into the file. And for append it will seek to the end of the file and add our new content over there. For file types, we have text and binary. So text does UTF-8 conversion and binary is the raw data that is stored in the file. Also with that, we don't want to unnecessarily keep copying this. So I'll actually explicitly delete the copy constructor and the assignment operator. So file, const file reference will just delete this kind of constructor, and we'll also delete the assignment operator for this copy constructor. So let's define some methods. To open a file, we'll just create a method called openFile. So the openFile will take a path, which is a string reference, a mode. Actually, this mode is the enum that we defined earlier, and file type. Now let's populate this method. So we have std input output stream base open mode. So this open mode is where we have to define what mode and file type we want to select. So I'll just do a switch statement. So if mode is read, then we'll do std input output stream in. So this is the input stream. Similarly for write it will be a output stream or a truncatination. And for append we're also writing to the file, so it will also be a output stream and it will be in the append mode. Also no two modes can occur at the same time, so we have breaks in between. Now we need a small check to see if the file mode is binary or not. If the file mode is binary, we'll just set the open mode to std input output stream binary. And now our open mode is ready. So let's open the file. We are doing, since this is a unique pointer, we'll just do make unique, and then the type is file stream of course. And what this does, it takes the path and open mode. So we have the path as a string reference already and the open mode that we have populated. So we have constructed a fstream. Now let's check if the fstream is open or not, because if the file does not exist then this fstring will not be there anyways. So we can just do file stream is open. If this is true, then it is all fine. If not, then we can throw that they failed to open, then we can say the path to the user. And that's it. We have our open file. Now actually let's fill the constructor. We will call open file. So open file, and this takes path, mode and file type. So we actually need to take all of this from the user, and I'll just copy and I'll just copy and paste it over here. So I'll pass the data, path, mode and file type. So whenever we are constructing an instance of this class, our file should be opened. Now for close, we'll actually check if the file is there and then we'll close it. So we have file stream is open. If it is open, if it is there and if it is open, then we'll just do file stream close. Actually, let me just put this in its own method. So I'll do void close and then I'll move this logic to that. Now we can just call the close function. Because there may be situations where user wants to close the file without relying on the disruptor. Now we have the basics ready, so let's write to the file. So over here, after this, I'll add a public method called write. So what the write will take, it will take a string reference. The string will be its data. So whatever is written in the string will be written to the file itself. So first we'll check if the file stream is there and we'll check the file stream is good. That means the file stream is not corrupted or it is opened. If everything checks with the file stream, we can just shift the data to the file stream itself. So we can do file stream then shift data. Of course, we are accessing the underneath stream data itself, not the pointer. So we are shifting the data to that underlying file stream. Now we can write in binary. So for that, we need a character array, and for ease of use, I am using standard vector. So this is a vector of characters which is passed to this function. And over here, like before, we will also check if the file is good or not. And next we'll do filestream.write. What write takes, it takes a character array and the size that to be written. So from the vector itself we can get both of this information. If we do vector.data, then data will return the underlying character array or underlying array of that vector. So we got the character array, and dot size will actually give the size of that array. So this operation will write, so whatever the data we stored in the vector to that file directly. So this is our binary write. Now moving on to reading the file. So first I'll do a read method which works on text files. So like before, we'll check if the file is open or not. And notice over here we are returning std string. So whatever text we are reading from the file, we'll create a string out of it and we'll return it. So once the file is okay, we will construct the string with all the characters that are present in that file. So for that, we will iterate over the file stream, and our stopping condition for this iteration will be the default constructor of the input stream iterator. So this basically means we'll keep iterating until the file stream is exhausted. So once the file stream is exhausted, all the characters from the file has been copied over to the string, and now the string holds and now the string called content holds all the data in the file. So you can just simply return it. Now reading a binary file also is similar, but we need to do one extra step. So to read a binary file, we'll also be using std vector to store the data and return it. We'll also check if the file is good or not. Next, we actually need to determine the size of the file. For that, we'll go to the end of the file, we'll query for the size, and we'll come back to the beginning of the file because we need to read the file now. So we cannot start reading from the end. So we need to come back to the beginning. Now once we have the size itself, we can create the vector with that size. Why we are not doing dot pushback to the vector? Because whenever we are doing dot pushback with a vector that is default constructed, so by default the vector will have a memory allocation of 8, whatever the data type underlying is, that size. So whenever we are exiting that limit, all that the vector will try to reallocate the data to a bigger buffer. So all these allocation, reallocation, and freeing the memory and all, this all takes very much time and waste of memory, and is a waste of memory. So we now have the size and we'll create the vector with that exact size that we need to store our data. So we have the buffer that we want to store into. Now we can call the read method and pass into that buffer that we want to read into, and the size of course. So the vector will be populated with the data from that binary file. And now we can just return this vector, and that's how we can easily read binary data. Also, we'll add isOpen method, so we can anytime query if the file is open or not before doing any of the read write operations. We actually have everything we need, but let me just add one more thing. So over here I'll just add the move constructor and assignment operator. So what the move constructor will do, it will use std move to move the file stream to that new assignment. So the file stream will not be copied, it will be moved to the new data. In our constructor, let's add the default type to file type text. So we'll do file type text. So by default, if nothing is mentioned, our file will always be open in text mode. And to binary mode, we need to override this default. Now everything is in place, so we can start testing this. So we have included the file.h because we have set the include folder as the include directory of this application. So we can directly include it. We also have iostream to print the data in the console, and we have vector to test out the binary mode. Now let's go through the test code. So first we'll say that we are writing the text data to a file, and we'll open the file in a write mode. So at this point the file does not exist. So it will create the example.txt and it will open it in write mode. Now our data can be passed to this write method as a string. So you can see this is inside a scope. Why this is? Because when we are creating this file, it will open the file. And once the scope is over, our destructor inside that we have the close method. So the scope will make sure that whenever we are leaving it, the file will be closed automatically. Now to read the data back from the file, we can open it in the read mode and we can use the read method where we will be returned a std string. Now we can store the string and print it. Next, for the binary method, I have a binary data, a character array specifically, which is a vector. Now my binary data, I can write it and I have to specify the file mode as binary over here because if you recall, the file mode is by default set to text. Now I can just simply write my binary data by passing the vector. Now to read back from the binary file, we can just open in read mode with the binary file type. Now we can just call the read binary method and we should have the vector containing all the character arrays from the file. This simple logic is just to print the data. So let's build and run it. So I'll just build it over here. So build finished with exit code 0, which is success. And if I run it, you can see that testing text mode, writing text data to file, reading text data from file, and actually this is the content we have written to the file. So let's verify that. So I'll go over here. We can see example.txt has been created and the data has been written to the file. So we have written this file data to the file and we can also read back it from the file. For the binary testing mode, see writing data to binary file and then reading the data back from the binary. So let's open the binary file. I'll just open it with hex editor. So yeah, this is showing in hex, but you can see it in binary or any other format also. Basically, binary files does not do the UTF encoding decoding by default. So whenever we are using a file handle class in let's say game engine where you want to load massive scenes and you are doing UTF conversions in between to just convert it to a string or stuff like that, then the operations will be very slow. Instead, binary data from the game engine is directly written to a file, and whenever the game is being run, the binary data as it is being read from the file and is used. So this kind of data will be present in the binary file. This is actually hex representation, but yeah, zeros and ones will be in that. So you can see that these 48 represents 01001000. So this kind of data will be written to the file. Now this hex editor, this shows us what each hex corresponds to. So we have a hello binary over here. That is the data we wanted to write over here. If you can see, that has been passed as a vector. So the testing also passed. Our application is running pretty fine, and our file handle is just header only, so it can easily be integrated into any project. Thank you for watching this video. Thumbs if you liked it. Do share it with your friends and family, and make sure to subscribe for more content and let me know in the comment section below.